Hello everyone, in this video we will see how to find the argument of any complex number. So what is argument? Argument is angle made with positive real axis. Okay, in crude way I can say this argument is angle made with positive real axis. If this is the positive real x-axis and we have a complex number z here, then I can say that the angle between OZ and OX is the argument. I have deliberately not made the y-axis. Okay, so I can show you something here. So someone can say that okay, this is the argument, while some may say this may also be the argument. Okay, so how to deal with this? We have put some restrictions on arguments, which is as follows. Okay, so if theta is the argument, then theta must lie between minus pi and pi. Pi is inclusive. Okay, and there is a convention to measure the angles in the clockwise and anti-clockwise direction. If theta is calculated in counterclockwise direction, CCW, okay, anti-clockwise or counterclockwise, then it is taken as positive. If theta is calculated in clockwise direction, then it is taken as negative. Okay, so what I mean to say is, if I from this line segment OX, if I measure any angle in the clockwise direction, suppose this is 30 degrees, so actually I will say that this is minus of 30 degree. Okay, in the anti-clockwise direction, if I measure, I will say this is plus 30 degree. Okay, now we have to put this thing in mind, the convention and the range in which argument angle theta will lie. Okay, so we can at max have 4 different cases. One is complex number in the first quadrant, in the second quadrant, in the third quadrant, and in the fourth quadrant. Okay, so let me join all this with the origin. Okay, now I again see there are two angles. One is this, and this, and this. Okay, in the anti-clockwise direction. Okay, and one angle is in the clockwise direction. Okay, fine. Now I have to notice that which angle is falling in this range. Okay, so you see, in each case you can say that one of the angles is falling in that range and one of the angles is not satisfying that range. So I can say that in the first quadrant this angle satisfies the condition while this one doesn't. In the second quadrant this angle does. In the third quadrant this angle does, which is measured in the clockwise direction. In the fourth quadrant as well, the angle measured in the clockwise direction does our job. Okay, so now we are clear how to measure the argument in all the cases when the complex number lies in first, second, third or fourth quadrant. But let's see how to calculate these angles. Okay, suppose I have the complex number z here. Okay, so when I join this, I get this theta. You have to calculate this theta. Suppose z is x plus iota y. So I can say this distance is x and this distance is y. Now I can say tan theta is equals to mod of y upon x. Actually here mod was not required, but to keep the symmetry I am using mod here. Okay, one more thing, while we will be calculating this tan theta, we will simply ignore the signs of x and y. Okay, So 4 minus 3 iota and minus 4 plus 3 iota, minus 4 minus 3 iota, all will be considered same. I have to take only the numerical values. Y will be 3, x will be 4. Okay, I will show how to manipulate the signs on later stage. Okay, so tan theta is mod of y by x, and I think from here we get theta is equals to tan inverse mod of y by x. So in this case, this is the argument, simply tan inverse mod y by x. Okay, how to tell if it lies in the first quadrant? Obviously x and y will be positive. Fine. Okay, now let's see what happens in the second quadrant. This is z x plus iota y. I am not considering the signs of x and y. Okay, so this length is x and this length is y. Suppose this one is theta. Okay, this one is theta, then I will say tan theta is equals to mod of y upon x, and theta is equals to tan inverse mod y by x. But in this case the argument is this angle alpha. Okay, so what is alpha? Alpha is pi minus theta. So this becomes pi minus tan inverse mod y by x. Okay, so this is the argument in the second quadrant. Let's talk about the third quadrant. This is z x plus iota y. This is theta, and this length is x, this length is y. Again I have tan theta is equals to mod y upon x, and theta is equals to tan inverse mod y upon x. But the argument in this case is this angle alpha taken in the clockwise direction, so it will be negative. So first, what is the numerical value of alpha? Numerical value is pi minus theta. Okay, but minus alpha will be, since it is measured clockwise, I have to take negative of it, so that will be theta minus pi. So argument in this case is tan inverse mod y by x minus pi. This is the argument in the third quadrant. Okay, finally in the fourth quadrant I have z x plus iota y. This is theta, this is x, and this length is y. Again tan theta is mod y by x, and since this theta angle is measured clockwise, so the argument will be minus theta. So argument is theta is equals to minus of tan inverse mod y by x. Okay, I have to add the negative sign because it is taken in the clockwise direction. Now let us take an example, okay, to see if we have got the concept or not. So suppose we have a question, find argument of the following complex numbers. Okay, so let it be 7 plus 8i, next is 7 minus 8i, third is minus 7 plus 8i, and fourth is minus 7 minus 8i. Okay, fine. So what we have seen, we have already seen that in this quadrant the argument is theta, in this quadrant it is pi minus theta, in third theta minus pi, and in fourth minus of theta. Okay, so how we are calculating theta? We are calculating theta by simply taking the numerical values of the real part and the imaginary part. We will simply ignore the signs associated with the real and imaginary parts. Okay, so for all the cases I can say theta is equals to tan inverse mod of y by x, which is tan inverse 8 by 7. Okay, this is simply tan inverse 8 by 7 theta. Fine. So first is 7 plus 8i. Simply now we will see the real and imaginary parts signs. Okay, so this is positive means in first quadrant simply it will be theta, that is tan inverse 8 by 7. Simply this will be the argument. 7 minus 8i cap. Okay, now let's see for 7 minus 8i. So it lies in the fourth quadrant, so I can say the argument is minus tan inverse 8 upon 7 simply. Okay, and for minus 7 plus 8 I cap, uh, which lies in the second quadrant, I can say it is pi minus tan inverse 8 by 7. Okay, and now minus 7 minus 8 I cap, so this lies in the third quadrant. So what I can say, this is theta minus pi. So putting values, I can say it is tan inverse 8 upon 7 minus pi. Okay, so like this we can find the argument of the complex numbers, and I have taken such an example that will clear all your confusions, because in my experience I think the positive and negative signs of the real and imaginary parts are the actual headache for the students. So that's why I have taken such an example. I hope things are now very much clear to you, and I believe from now onwards you will not find it difficult to find the argument of any complex number. Okay, so let's stop here. Thank you very much.